Hi, and welcome to Genetics Decoded. I'm your host, Sharon Palmer. Please note that the information that we're presenting here today is not to be taken as medical advice. It really is just for your information and your knowledge base. If you enjoy the podcast, please remember to go in and like and subscribe. It doesn't cost you anything and really supports what we're doing. I'm going to start by asking you a question. What can't you live without? Give you a moment to think about that. Did some of you say coffee? Did some of you say chocolate? Maybe some of you said your mum. I can't live without my mum. I guarantee you that not one of you said mitochondria. Can't live without my mitochondria. And you might not have even heard of mitochondria. Mitochondria are the little tiny energy producing cells that really take your food and turn it into energy. And if your mitochondria are not working, then your body is not going to be functioning. Everything starts with the need for energy. And your mitochondria are one of the most important areas to focus in on. So if you've got problems with energy, we need to focus on mitochondria. But if you want to live long, you've got to focus on mitochondria. If you want to live healthily, you need to focus in on your mitochondria. Today, we're going to take a really deep dive into mitochondria. What are they? How do you look after them? What are the things that could damage them? What are the kind of signs and symptoms and diseases that are associated with poor mitochondrial function? Because what you will learn here today could make a profound difference to your long-term health and well-being. Who listening today has problems around energy? Maybe you're getting a little bit older, your energy isn't as good as what it used to be, and you put it down to, I'm just getting a little bit older, that's natural, that's what I should expect. Or maybe you've got some really profound long-term issues with energy. You've been diagnosed with chronic fatigue. I see a lot of patients in clinic who have spent years trying to investigate and get an improvement in their energy to find out that they're just kind of going nowhere. Again, if you look at the industry that's been built up around supporting our energy, look at the number of people per day that are having caffeine as a pick-me-up, like they can't get going until they get that first cup of coffee in. Then you've got all these energy drinks, like we've only recently seen them come into the market. And again, it's all around lots and lots of caffeine, lots and lots of sugar, all trying to get you ready to go for the day. And the supplement industry, again, around energy, huge amount of marketing, a lot of particularly B vitamins, multivitamins, all around getting your energy better. And it's really important to focus in on your energy. One of the things I see a lot in patients is by the age of about early to mid-30s, a lot of people start to report, energy is a bit of a priority for me. It isn't what it used to be, and I'd like it to get better. But people often don't really think around, where's this energy being produced in the body? And what we're going to look at today is something called your mitochondria. You might have heard of the term, it might be new to you, but your mitochondria are your little energy producing cells in your body. And if you're really wanting to focus in on energy and energy production, you should first and foremost start with your mitochondria. If you want to live a long, healthy life full of energy, you're going to need your mitochondria to work well. I could give you this big long list of, just what your mitochondria do, but it's kind of a little bit boring. What I thought today is that if I was placing a job description on Seek for mitochondria, or I was interviewing some mitochondria for a job, these are the kind of things I would be asking and looking for. And you'll probably see at the end of this that there's not too many of you that would put your hand up for the job. If we have a look, the primary role, there's a lot of responsibility with this role. If you don't do your job well, there's a pretty good chance that we're going to die. And so it's very important that you show up every day, take your job really seriously, because the consequences could be catastrophic and fatal. Let's have a look at your job description. What would be expecting of you? With a high degree of efficiency, you would need to take the food that's ingested and the oxygen that's breathed, and you would need to turn it into adenosine triphosphate. That is called ATP energy. That is your primary job, is to produce this ATP energy. You will be responsible for providing this ATP energy, so you and your fellow mitochondria, for 36 trillion cells in the body. So you can see it's a big job. Each of those cells is going to require 10 billion parts of ATP every single day. And you're going to be playing a role in providing 10 million parts of ATP energy for the day. So again, it's a big job. The most important organ that you really need to look after and make sure you provide plenty of ATP energy to is the brain. Okay, the brain is going to use up the majority of our ATP energy on a day-to-day basis. So make sure the brain doesn't run out of that ATP energy. Let's have a look at the kind of conditions and hours that we're expecting of you. You will need to be here every day, Monday through Sunday. It is 24/7, and it literally is 24/7. There will be no coffee breaks. There will be no lunch breaks. There will be no sick leave. There will be no personal leave, because we know that this ATP energy that you're needing to produce, it can't be stored. So you can't work really hard and then take a little bit of a break. You're going to need to be producing this ATP energy day in and day out. So you will need to be here 24/7. Your KPIs will all be around this ATP energy production. That is really the only thing that really matters. If you fail to deliver on these KPIs, we will terminate you immediately. We won't give you any warning. There'll be no second chance. We will just get rid of you, and we will immediately replace you with another mitochondria that can do a better job. Let's have a look at your length of employment. It's a little bit hard for us to be specific here. It's going to really depend in which part of the body, which organ will place you to do your job. But it could be for as little as a month, but it certainly won't be any longer than 3 months. So we'll be looking at somewhere between 1 to 3 months of employment. And I want to bring your attention to this really important termination clause, is that once you've finished with us, there will be no possibility of re-employment. And in fact, even if you do a really, really good job, you produce all of the ATP energy that is required of you, we are still going to terminate you at the end of your employment. So that's kind of the life of a mitochondria. And, the thing is, there are trillions of these mitochondria working in your body every single day, day in and day out. Their energy production has to be consistent. And if it's not, you're going to notice that. And one of the ways that you're first going to notice that is that your energy production is going to decline. So stop thinking that you're going to, take a cup of coffee and it's going to give you this jolt, or you're going to swallow a multivitamin. Start to think of, well, my mitochondria might not be functioning as well as they should do, and how am I going to go in and get my mitochondria working better? And that's what we're really going to look at today. If we look at your mitochondria and where they are in the body, pretty much every single cell in your body has these mitochondria. The only cells in your body that don't have mitochondria are your red blood cells. But on average, there's probably around 1,000 to 2,500 mitochondria per cell in the body. So they're very, very tiny, and you have a lot of them within every cell. There's this need to produce a lot of cellular energy. But there are some cells like your neurons that have even higher levels. If we look at some of the research, there could be as many as 2 billion mitochondria per neuron. So that's really high. And of course, your body is smart. It's not going to put a lot of mitochondria that can produce a lot of energy into a tissue or a cell that doesn't need it. And that's because, we mentioned earlier that the brain has one of the highest requirements of ATP. You need a lot of mitochondria to do that. But what you will also see is that if your mitochondrial function is declining, one of the first places in your body that's going to really suffer is going to be your cognitive health. And you'll see as we go through this podcast, the real tie into mitochondrial health and really good neurological health as well. So again, this is not just about energy, this is around how really key organs are working. But your brain is really, really dependent on healthy mitochondrial function. How many of you want to live a long life? And that can be a bit of a double-sided question. I think most of us would like to be around for a long time, but we want to be healthy. If we're incapacitated, if we're bedridden, if we've got a lot of chronic diseases, then it's not much fun. And I think what we're seeing today, the terminology that often is thrown out there is lifespan versus health span. Yes, we want a long lifespan, but we also want that to be matched with our health span so that as we age, we stay healthy. And if that is your ultimate goal and objective, then it is so important that you get your mitochondria functioning and keep them functioning, because we know from the research that mitochondrial function is absolutely tied into longevity. The healthier your mitochondria are, the better they produce energy, the longer you will live for, and the healthier you will be. And we don't just see that in humans, we see that across a whole range of different species. And again, it comes back to, if you're interested in your health, focus on the things that will make a difference. So if you're doing all of these things and there's nothing in your protocol or in the choices that you're making that are directly impacting on mitochondrial function, you have to ask, well, how successful are you being? There's only 24 hours in a day. There's only so many things you can do. And I think one of the important things to do from a health point of view is to make sure you're understanding and focusing what you're doing, what you're taking upon mitochondrial health. If your mitochondria are so important for your health, what do you really need to do to keep them healthy? And there's kind of a whole lot of things that you could possibly think of, but I've broken it down into some core categories here. One is around nutrients. You have to think that anytime anything, any animal, any human, any person is working hard, the harder you work, the more nutrients, the more fuel you need in order to do your job. And that's exactly the same with your mitochondria. It is so important that you keep the required nutrients coming into your body so that they have the fuel in order to work. And we'll have a little bit more of an in-depth look at what those nutrients may be. We know that environmental toxins, particularly heavy metals and persistent pollutants, organic pollutants in the environment, really knock mitochondrial function on the head. So again, as we're living in a more toxic environment, a more polluted environment, our mitochondria are being negatively impacted. We know that oxidative damage is really, really important. And this is kind of one of the top things that if you're trying to focus in on mitochondrial function, you really want to be focusing on this process of oxidative stress. We know that high oxidative stress will damage the mitochondria, but this is where you can get caught into a catch-22, that if you're under high oxidative stress and oxidative stress damages the mitochondria produce less energy. So high oxidative stress will lead to decreased energy production. But when your mitochondria are not working as effectively as they should do, they start to produce more of these free radicals. So it then triggers more oxidative stress. And you get stuck in this cycle Oxidative stress goes up, mitochondrial function goes down, more oxidative stress, and eventually it gets to the point where the mitochondria are working so ineffectively. That's where that kind of clause comes in and says, well, you're not doing your job, so we're just going to get rid of you. We're going to, get rid of you, and we're going to bring in a new mitochondria, and we're going to get them to replace you. The problem is that oxidative stress is part of what's going on in your body. So that new mitochondria will end up also being under high oxidative stress. So one of the really important pathways to understand is this pathway of oxidative stress. We know that many prescription drugs are really damaging mitochondria, and we're going to take a really good look at those prescription drugs, because what you're going to find is a lot of them are just over-the-counter medications, and a number of them are very commonly prescribed prescription drugs. So without you even knowing it, a lot of things that you're taking, whether they're prescribed by your GP or you're just buying them over the counter, could be having really, really negative impacts upon your mitochondrial function. And for any of you who like to have a beer, a bit of a glass of wine, alcohol is not good for mitochondrial function either. Let's have a very, very good look at the over-the-counter medication and the prescription medication that can damage your mitochondria. And even as I go through this list, this is not for you to go, oh, I just have to stop taking that medication. That could be pretty dangerous to do. But what I want you to understand is things that you might not even be knowing can go in and really damage your mitochondria. And long term, you want to have a really good look at whether you're taking these things and what you could do to decrease that intake. One of the first over-the-counter drugs that we're going to look at is acetaminophen or paracetamol. So any of you who are taking paracetamol, and that is often a lot of people. People are taking it to relieve pain. They may be using it on a day-to-day basis, but acetaminophen, paracetamol, is very damaging to your mitochondria. The other is aspirin. So again, you think, well, I'm taking paracetamol, maybe I'll switch over to a different class of drugs. Or maybe you've been prescribed low-dose aspirin to thin out your blood if you've got some issues around cardiovascular risk. But again, not knowing that it's negatively impacting upon mitochondrial function. Then we look at antibiotics, and who listening has not taken an antibiotic at some point in their life? It would be very, very few people these days. When we go in and look at the research around antibiotics and impact on mitochondrial function, and this is across animal models and also in humans, is antibiotics are incredibly damaging to mitochondria. In fact, maybe more so than a lot of the other things on this list. So again, if we're using antibiotics, and there's times and places for those, but again, this judicious use of prescription medication is really important. You may be using it for one benefit, but in the background, it's creating other problems. We know that AZT, so probably not a lot of you using AZT, it's a HIV drug, but again, leading to a lot of mitochondrial damage. Any of you who are into a bit of the drug scene, you're using cocaine or you're using methamphetamine, it really impacts around mitochondrial function. And one of the things I for a while there, I got very interested in people who are using methamphetamines. And you would see these, if you Google it online, you can go in and you can look at the before and after. So you see someone before they got addicted to methamphetamine, and then you might see a picture of them sometimes only a year or two later, and it's looked like they've aged 40 or 50 years. And again, you're seeing this enormous amount of damage to the mitochondria. And that's one of the consequences. When your mitochondria are not working, your rate of aging will go up. And so you can see that in the way that you look, in the texture of your skin, the amount of wrinkles. But yeah, both cocaine and methamphetamine don't do your mitochondria any good at all. If any of you are taking any antifungal drugs, that's also not going to be good for your mitochondria. And then we've got your NSAIDs, your non-steroidal anti-inflammatory drugs. And again, how many of you are taking them who have got chronic pain, arthritic pain. You're using them again on a regular basis. So you can see a lot of the drugs geared towards pain relief and controlling inflammation in the background are really harming our mitochondria. And then probably the one that maybe more of you are using than any of these other drugs are the statin drugs. And so statin drugs are prescribed for high cholesterol. And I don't know whether any of you are aware of this, that when you're taking a statin drug to deal with your cholesterol, that statin blocks the activity of a particular enzyme. And so you block the activity of the enzyme, and downstream from that is cholesterol production. So cholesterol production declines. But in that same pathway is the production of CoQ10. And the activated form of CoQ10, which is ubiquinol, is really important. It's one of those really key nutrients that we're going to look at around supporting mitochondrial health. So you go onto a statin drug, but what you do is you suddenly decrease your own production of CoQ10, and therefore you decrease that production of the ubiquinol, and that's going to have a direct impact upon mitochondrial function. And this is where you see, and for some of you who may be on a statin drug or have been on one in the past, is some people who go onto a statin drug very quickly report that they just feel really, really tired. They're running out of energy. They're ending up with a lot of muscle aches and pains. And those are both signs of damage to the mitochondria. There's also another drug called L-DOPA, which is prescribed to people with Parkinson's. And again, we see that it's damaging the mitochondria. And again, I look and I go, wow, if we look at one of the clinical risk factors, like when you're getting mitochondrial dysfunction, what are one of the diseases that you would see? It would be Parkinson's disease. And we'll look at some more of these diseases in a little while. But I look and I go, well, if Parkinson's disease is partly a function of poor mitochondrial function, and then we put people on L-DOPA, which is to treat that disease, but what it does is make the underlying mitochondrial dysfunction worse. Like, what are we doing? Or do we, if we're using these kinds of medications, do we also really need to focus on protecting and supporting mitochondrial health? And so if you're taking any of those drugs, and probably most of you are taking at least one of them, is knowing that you want to go in and think about, what is going on with my mitochondria? How could I go in there and support it and protect it? If your mitochondrial function is really important, maybe the first question is, as we've kind of got to this part of the podcast, you think, I wonder, how well is my mitochondria working? What could I do? Is there a test that I can do to go in and look at the health and the functioning of my mitochondria? And it's really not that easy right now. Probably in the not too distant future, with genetics becoming more mainstream, with the advances in technology, there'll be better and easier ways to go in and really assess that mitochondrial function. And I'm going to talk to you today in a little while around some of the signs and symptoms, so things that you could start to look for, but going in and really measuring that mitochondrial function is a ways in the future. One of the best tests that you can access reasonably at this point in time is a test called 8-OHDG. It's a urine test that you would do, and it is a marker of the amount of damage that has been done to the mitochondria and to the DNA through oxidative stress. I used to track that marker very regularly in a number of my patients, and what always surprised me was often how high that marker was. But I could also see by going in and, first of all, looking at the genetics around oxidative stress and mitochondrial function, putting in interventions that directly impact at a genetic level, I could see that damage marker could come down within normal. It is not that easy to access that test. You would need to go through a functional laboratory. It's not something your GP is going to do as part of a standard pathology panel. And, there's a cost involved with it. It's probably up around the $130 mark to do that. But there is the capacity to track some of those markers and put interventions into play, and then see that over time that damage marker comes down. And There was only one patient I ever saw that we couldn't bring that damage marker down, and this was someone that just had very active, very aggressive cancer. So, there are ways you can go in and get some insight. If we look at, what are the types of diseases that have been linked back to mitochondrial function? And I'm going to go through those one at a time right now because some of these are pretty prevalent in the community. The first one, and as we touched on this before, is early aging, particularly if you're aging rapidly or you think you look older than what you should be. And that always surprises me in clinic. I have people come in for the very first time. I don't know anything about them. And what I have is their age. And in some people, I think, wow, they look really good for their age. They look so much younger. They look healthy. They look young. But then I can see other people who might be 50 or 55. And I think they look about 10, 15, 20 years older. And this is where if you feel that you're aging rapidly, this is not about going out and getting a whole bunch of Botox and trying to get your fillers in. It's about going in and saying, I need to be working around supporting my mitochondrial health. It's not going to be just on the surface around your skin. It's going to be impacting internally across all of your organs and systems as well. Then we come to motor neuron disease, or ALS, so amyotrophic lateral sclerosis. So motor neuron disease is a neurodegenerative condition, and I've had first-hand experience of that. I had a brother-in-law that died from motor neuron disease, and it was quite shocking to see the rapid deterioration that somebody goes from, he was a tennis coach and he started to have some issues around just not his gait, his walking. He was starting to get some weakness and finally went through this diagnosis. But I remembered within a 4 to 5 month period, he was a professional tennis coach. He went from full-time employment to literally not being able to walk. And, going through as he was seeing all of these neurologists and, at the end it was like, okay, you've got motor neuron disease and, we don't know what to do and we can't help you and you should just get your affairs in order because most people are going to die within 5 years. And that's a shocking diagnosis. But what we're starting to learn now is you don't want to just give that information to people, is that, there's this capacity. Let's go in and look at people's mitochondrial function. Around motor neuron disease, it's a very important area to investigate. And remember me saying earlier that one of the biggest requirements for ATP energy is in your brain. And so all of these neurological conditions are so tied into mitochondrial not working and not being provided with enough energy. Then we look at Alzheimer's disease, and right now Alzheimer's disease is the number 1 killer of Australian women and the number 2 killer of Australian men. We're an aging population. People are getting very concerned as they begin to age that they do not want to lose their cognitive health. And again, we've got to come back and look at how well is your mitochondria working? You need to keep producing this energy for those neurons to continue to function. Autism is also on this list. And again, if we look at the rates of autism over the last 20 to 30 years, again, we're seeing this rapid increase. But again, we've got to come back to looking at mitochondrial health. Cardiovascular disease, again, number 1 killer of Australian men. And certainly, I think it's the number 2 killer of Australian women. Lots and lots of people suffering heart attacks, strokes. And again, you've got to come back and get your mitochondria working. So are you seeing a little bit of a pattern here? Some of the major diseases that are killing us, we have got this common core of needing us to keep our mitochondria working. And once we know these things, we can go in and we can start to shift our focus and our protocols to supporting that mitochondria. The other disease on this list is chronic fatigue syndrome. And I've seen a lot of patients clinically with chronic fatigue. It's very rare where people come in and say, I had really severe chronic fatigue for a few years and it's all gone now. It was just something that I had. You're often seeing these people who are having issues over decades. It might improve a little bit, but then they also have real periods where it really begins to get a whole lot worse. So anytime I have somebody come in around who's got chronic fatigue, I go, we've got to go in and we've got to go down to a cellular level. We've got to look at how this mitochondria is working, the ability to make that cellular energy. Where does it all begin with? Dementia is on that list. So Alzheimer's is the number one cause of dementia, but there's other causes of dementia. But again, this mitochondrial function is important across the board. Huntington's disease, again, another kind of neurological decline. Migraine headaches, that kind of shocked me on that list, is, how many people are getting migraines and how many ever thought that, oh, maybe my mitochondria are not working as well as they should do. And then what we also have is Parkinson's disease. And again, we were talking about how some of the medication for that may actually increase mitochondrial dysfunction, but it's a cause. And we're seeing that there's a couple of really key genes. There's something called PINK1 and PARKIN, and we're seeing that they're playing such a big role in mitochondrial function and playing a big role in the risk of developing Parkinson's disease. Now, I always say to my patients, we're at the point right now, you shouldn't be waiting to get a diagnosis. You don't want to wait to find out that you've got Parkinson's disease or you've got cardiovascular disease or you've got diabetes. And in fact, that was one of the ones I just left off that list, is diabetes. People who've got diabetes, mitochondrial function really needs to be addressed. In fact, one of the big risks around people who have diabetes is their oxidative stress levels are through the roof. But you don't want to wait until you get a disease. What you want to do is try and act early. And that's the real benefit of looking at genetic screening, is where we're moving into the realm of preventive and predictive health. But what I want to do is look at some of the common signs, the early signs that can indicate mitochondrial dysfunction. Just because you have these symptoms doesn't mean you have mitochondrial dysfunction, but it means that you should begin to consider. And when you kind of see this or hear this list, you're going to realize that things that we might be experiencing that we just kind of go, oh, I'm getting a little bit old, or that's nothing. Or, we go off to our GP these days and, just some kind of very simple tests that could be done and that might have been done in the past that are not being done could give us some real insights. And again, I'm going to go through this one at a time. There's something called lactate that you can measure in a blood test. And it's probably reported in a fairly standard blood test, so it might be reported when you're looking at a liver function test or your UNE. You can also order up lactate. But if lactate is high in the blood, it's a real sign that your mitochondria are not working. And again, these pathology results, someone often just looks and says, oh yeah, it's a bit high, don't worry. You would want to be acting as you're starting to see those lactate levels begin to rise, not waiting until they're over and above that reference range. We know that the loss of muscle tone is a real sign of mitochondrial dysfunction. And again, that your movements are not just as good as they used to be, or you're starting to get a little bit more clumsy, or that there's a lot more flexibility in the joint. And again, these can be all signs of mitochondrial dysfunction. And in adults, it's almost like where if you've been kind of laying down or sitting down and you go to stand up, that's just getting harder to do. And how many do that? Like, you hear people now, they go to stand up and they make all this noise. Ugh! It's like this enormous amount of effort. What you're going to see is holding on and preserving muscle is critical here. And loss of muscle and loss of muscle tone is not a good sign. Muscle weakness. And again, I had a patient the other day who came in and said, she used to work in a supermarket, and she would be standing up and bending down, doing price tags all of the time. And the other day she went to kneel down and she went to get up, and she's like, oh my goodness, that's like really, really hard for me to do. Like, I'm so much weaker than what I was. And we have to go, oh, well, it's just not because you're getting older and you don't have enough muscle, but taking signs of muscle weakness as, you want to step in and you want to be very proactive, but you want to go in make sure your mitochondria are doing their thing as well. Epileptic seizures. So if you've had them as a child or you're starting to develop them as an adult, you would want to go in and investigate around your mitochondria. And hearing loss. And how many of these do we go, it's just a sign of getting older? And in a way, that's true, because as our mitochondria are not working well, our system is not working as well, and we'll start to see that. But we see that hearing loss is relevant across all age groups. Doesn't matter what age you are, the loss of hearing is directly tied into how well your mitochondria are performing. And again, for any of you who are, what you want to do is do this regular screening where you're going off and getting your hearing checked. And if it's not as good as it should be, don't just go, oh, I'm just getting older. It's a sign to be a lot more proactive around your health, getting a lot more specific around what you're actually doing. Any neuropathy. So neuropathy is any kind of pain or tingling or loss of sensation throughout the body, normally in the hands and the feet. I get a lot of patients come in and they say to me, I'm just getting pins and needles all the time and I've never had it before. And again, they've often tried lots of things. They've seen their GP and it's kind of an obscure symptom. But again, if you're starting to notice that, and this is where, people who are diabetics, that's one of the really big things is the risk of this peripheral neuropathy. And again, this importance of keeping your mitochondria working well. Then we're looking at what we call this knee-jerk reaction. And when you see kind of old-fashioned, people sitting in a doctor's surgery, they're sitting on the end of the bed and the doctor takes out that little, kind of looks like a little triangle and taps them on the knee and their knee should shoot out. That's a knee-jerk reaction. We've used it for other things, but and so something as simple as that is tied into declining mitochondrial function. Who's had one of those done recently? I don't remember. I've seen it done at certain times, but it's certainly not a standard test that I think most people would have done these days. And then the other clinical sign that you can look at is weakness of the eye muscles. So the muscles that control movement, so moving it up and down, like holding them in place and around vision. So again, the basics like getting your eyes checked, getting your hearing checked, but being proactive, not just writing it off as like there's nothing that I can do about those. That's where all of those conditions, all of those signs and symptoms go back in and really start to give your mitochondria a little bit of love and attention. One of my little pet peeves around podcasts is that people want really quick and simple interventions. Oh, that's a problem. Just tell me what to take and I'm going to run out and I'm going to buy a couple of supplements. And the right supplement here could be really important, but that is not your starting point. If your mitochondria are not working well, the first thing to do is to establish why they're not working well, and then make sure you get the right intervention. And this is where genetics can be such a powerful tool. Is we had spoken around the role of oxidative stress. And for me, at a clinic level, dealing with oxidative stress to support mitochondrial function is the first and foremost. Now, your mitochondria are producing a lot of this ATP energy. And, like everything, you are producing something that you want, but you're also producing these waste products. So in the production of this energy, you're producing waste products that are called free radicals. And free radicals are what cause oxidative stress. For any of you who've been listening to the podcast, we've recently done an in-depth look around oxidative stress, and I would recommend you go in and listen to that. It'll give you a lot more detail. But you've got 3 primary antioxidants. If you want to control oxidative stress in the body, those antioxidant enzymes need to be working. And the way that they work, their ability to work effectively, is genetically determined. And you can go in and very easily see how well do my antioxidant enzymes work. But there's one in particular that you really need to focus in on around mitochondrial function, and it's called MSOD, manganese superoxide dismutase. It is the enzyme that is put directly within your mitochondria to get rid of free radical production. And that's a smart thing, right? Your mitochondria are producing all of this energy. They're throwing off all of these waste products that could interfere with how well they work. So your body puts this antioxidant enzyme directly there. You make these free radicals, your enzyme quenches them and removes it. Everything's nice and balanced. Your mitochondria keep working, because what we know, the minute your mitochondria stop working very well and these free radicals build up, those free radicals don't just stay within the mitochondria. One of the causes of why the rest of the body is under high oxidative stress is those free radicals leak out of the mitochondria and they start to impact on the rest of the body. You need to know how well your MSOD enzyme is working. And in some people, it is working, at least 40% decreased in function. There are things that you can do that will upregulate the enzyme itself at a genetic level. And that's not the things that are commonly in the market. And they're also things that I just don't give a name to, because I think there's so many risks in just buying things over the counter that you just don't know what's doing. But go in and find out whether your antioxidant, your MSOD, needs supporting, and then get the right support in play. That's where you'll get the single biggest outcome. We also know that this CoQ10, we'd spoken a little bit about that in response to statin drugs blocking the production of CoQ10. CoQ10 gets converted into ubiquinol, and ubiquinol is the activated form that really supports mitochondrial function. Your ability to take CoQ10, so whether it's CoQ10 that your body produces or it's CoQ10 that you take as a supplement, your capacity to convert it into ubiquinol is dependent on a particular enzyme, and that enzyme is called quinone reductase. And how well that works, again, is genetically determined. I saw someone the other day who's got real issues around chronic fatigue, and I said, we need to go in and look at this antioxidant system. And we went in and we looked at his quinone reductase. He had a double mutation in that. That enzyme simply did not function for him at all. And there are things that we can do that will upregulate and completely rescue that gene at a genetic level. So you can have really profound impact. But if you think that you can compensate for that by a few little things on the outside, it's just not going to happen. And so once I know that, then I can get the intervention right. And then hopefully what we begin to see is an improvement with that energy. But he's had low energy for such a long time. It's like he doesn't know, how's he going to ever feel better? But, when I look at that gene, I've been doing genetic testing for 13 years. I have only seen maybe 5 people at the most that have a double mutation there. So it's really significant for him. But we know that now and we can address it. So going in and using your genetics around that CoQ10 ubiquinol pathway. And we also see that glutathione is really important. And a lot of people hear about glutathione. It's very important around detoxification, but it's also really important around controlling oxidative stress and supporting your mitochondria. And this is not about, do not run out and just buy a glutathione supplement. They break down very quickly in the body. Your body needs glutathione 24/7. When you need it, it needs to be there. You do not want to be depending upon you supplementing to get your glutathione levels up. You've got to look genetically at how do I make glutathione? And again, we come back to what we call this methylation pathway. A lot of people have been starting to talk about methylation and MTHFR genes, but one of the roles of that methylation pathway is you've got something called homocysteine, and homocysteine will be pulled down into producing cysteine. And cysteine is your precursor to glutathione. So this is why you need your methylation pathway working, but there is a particular enzyme that is involved in converting your homocysteine into cysteine. It's the CBS gene that produces that enzyme. That enzyme is completely dependent upon activated B6. But again, your ability to activate your B6 is genetic. So can you see this domino effect? You want to look at your methylation pathway. You want to look at your capacity to produce activated B6. You want to get that working, because then if that pathway is working and you've got protein coming into your diet, whenever your body needs to make glutathione, it will do so. That's where you want to focus your attention, not running out and buying a supplement or doing an intravenous glutathione IV that, will break down within minutes, if not, hours. You need to sustain that on a daily basis. And again, your genetics can show you where these pathways may not be working. We also understand around the vitamin B12 pathway. And again, this is why the B vitamins are often touted as like, take this for energy. But again, it is so much more complicated than that. So whether you're thinking, I'll eat more foods high in B12, or I'm just going to take a B12 supplement because it's going to help, it's going to help my mitochondria. I say to you, B12 gets broken down and destroyed in your stomach acid. Can you produce the protein that binds to B12 and protects it? That is genetically determined. I can tell you that from a genetic test. Whatever kind of B12 survives your stomach acid and ends up in the small intestines, you've got 3 sets of genes playing a role in your ability to absorb B12 across the intestinal wall. Now, if you have genetic risks there and you can't protect B12 from being destroyed in the stomach, I'm going to say to you, you should do a sublingual or a intramuscular B12. You need to deliver it in a different way. But if you don't need to do that, you can just swallow it. So again, your genetics allows you to figure out what's the best way for me to get B12 into my body and get it absorbed. But you've got to transport it in the blood. Your receptor has to pick it up and transport it into the cell. All of those things are controlled genetically. But then when we come to the mitochondria, your activated B12, and again, your ability to activate it is genetically determined. Your activated B12 is going to play a really big role also in controlling oxidative stress. But, you've got to get your activated Bs crossed over the inner mitochondrial membrane, and then once they're in there, they're going to be used for energy. And that's a world away from thinking, I'm just going to swallow some B12 or I'm going to get my diet. You've got to track all of that so that you can get those activated forms directly within the inner mitochondria where they work. And there is no way you can know that without your genetics. But if you just take a supplement, you may be going absolutely nowhere with it. So your genetics says, what do I need? And how do I address this problem? Because if you get it right, you really can make a difference. And one of the things I see clinically is that if we really get some of these pathways working, people's energy, people notice it sometimes within days, often within a couple of weeks. So if you get it right, it can make a difference, but they're not the kind of things that you can guess. If you're interested in your health, if you're being proactive about, taking control of your health, you really need to make sure that you are focusing on your mitochondria. You need to go in and make sure that there are key nutrients to support that you are controlling oxidative stress. And if you can get that right, it can, in the short term, make a big difference to how you're feeling, particularly around energy on a day-to-day basis. But keeping your mitochondria functioning is really important for preventing a lot of kind of chronic diseases of aging, particularly the ones around neurological health, so Alzheimer's, dementia, Parkinson's disease, but also around keeping our cardiovascular system healthy. If you're really interested in supporting your mitochondria, I think one of the best ways to do that is start with some genetic screening around some key areas. If you want to go down that pathway and you're not sure where to start, please contact us at iDNA Health. We do a lot of screening around mitochondrial function, around B pathways, and we can then really prescribe the right nutrient intervention, the right supplement intervention. It is one of these areas you really want to get right. Put some effort in here and its impact will be quite significant over time. Thanks for listening to the podcast today. If we've started to increase your interest around clinical genetics and you think you would like to find out a little bit more, please feel welcome to reach out to us at iDNA Health Clinic. We're proud partners of this Genetics Decoded podcast. It's a real opportunity to get in touch with us and find out how you could go down this pathway yourself. If you liked the podcast, enjoyed it today, please go in and push all the buttons, like and subscribe. It really does make a difference and supports what we're trying to do here. We have a podcast release every Monday, so keep a watch out. All of our topics are around genetics and health, and we would love you to join us every week.